Hi, this is Somshakar from Maths Guru Academy. If you are watching the video for the first time, please subscribe to my channel and press the bell icon to get the notifications of my latest videos. So what Theorem 1.2 says, let P be a prime number if P divides A square, then P divides A, where A is a positive integer. So you know that what is prime number. So the numbers which have the factors 1 and itself, we call it as prime number. For example, 2, 3, 5, 7, 11, 13, so on, right? So what the statement they have given now, if P divides A square, P divides A square, then P divides A. This is the statement they have given. P divides A square, then P divides A. So we'll take one example now, then you will understand clearly. For example, P means what they have given. P is a prime number here. So let us take the prime number 2 here. 2 divides A square, will take one number. A square means 36. Getting? Then 2 means prime number. 2 divides, what is A? If A square is equal to 36, so this 36 can be written as 6 square, then A value will be 6, right? So 2 divides 6. So see here, if 2 divides 36, then 2 also divides 6, right? So this is the statement they have given. If P divides A square, then P divides A. Likewise, if 2 divides 36, then 2 divides 6. We can take one more example. Let us take one more prime number, 5. So if 5 divides, we'll take A square as 25. So 25, then what is the value of A? If A square is equal to 25, so then the value of A is 5, right? Then 5 divides 5 also, right? This is the statement they have given. If the prime number divides A square, then that number can also divide A. This is the statement they have given. If P is a prime number, if P divides A square, then P divides A, where A is a positive integer, right? So if 36 is divided by 2, then 6 is also divided by 2. If 25 is divided by 5, then 5 is also divided by 5. This is the statement they have given. Next theorem 1.3, we have to prove that root 2 is irrational. So for proving root 2 is irrational, we'll solve by considering root 2 is rational. Ulta, that means ulta. If they ask to prove root 2 is irrational, we'll consider this root 2 as rational and then we will prove root 2 is irrational. Let us assume, on contrary, root 2 is rational. Let us assume root 2 is rational. So rational means root 2 can be written as A by B. So root 2 can be written as A by B. That means since we took root 2 is rational, then root 2 can be written as A by B. So but there is one condition, that A and B are co-primes. What do you mean by co-primes? Co-prime means both A and B should have common factor 1. So both A and B should have common factor 1. So if both A and B having common factor 1, then we can say that A and B are co-primes, or in other words we can say that the HCF of both A and B should be 1. HCF of both A and B should be 1. Getting? And one more condition, that B must not be equal to 0. Since A by B is a rational number, this denominator must not be equal to 0. That is one more condition. So now root 2 is equal to A by B, right? So we will shift B to the LHS here. What it will becomes, root 2B is equal to A. Then the next step, will squaring on both sides. So next step we will do squaring on both sides. So what it will become now, root 2 into B whole square is equal to A square, right? So next step, So root 2b whole square means this square is for both root 2 and b, right? Root 2 into b whole square means this square is for both root 2 and b also. Here square and square root cancel, remaining is 2 and this b square as it is. So therefore root 2b whole square can be written as 2b square is equal to a square, right? So this a square have the factor 2. So from this condition 2b is equal to a square, we came to know that 2 is one of the factor of a square, right? Therefore 2 divides a square, that implies 2 divides a also. So if 2 is a factor of a square, then this a square can be divided by 2, right? For example 6, what are the factors of 6? 2 into 3, right? If 2 is a factor of 6, then this 6 can be divided by 2, right? 2 ones are 2 threes are, so we can divide this 6 by 2. Or if 3 is a factor of 6, then this 6 can be divided by 3. So if 2 is a factor of this a square, then this a square can be divided by 2. Also this a can be divided by 2 as theorem 1.2 says. So see here, if 36 is divided by 2, then 6 is also divided by 2. So likewise if 2 divides a square, then 2 also divides a. So let it be equation 1. Getting? So this is how we written this one from theorem 1.2, right? So next, let a is equal to 2k. So we can take a is equal to 2k. Why? If 2 divides a, then we'll get some integer, right? If we multiply that integer with 2, then we'll get a. For example, if 10 is divided by 2, we'll get 5, right? Then if we multiply that 5 with 2, we'll get 10, right? So likewise, if 2 divides a square, we'll get some integer. If we multiply that integer with 2, we'll get a, right? So this is equation 2. Substitute equation 2 in equation 1. So what it will becomes? Equation 1, 2b square as it is, 2b square is equal to, in place of a we can write 2k whole square. So square is there, we kept the square as it is. So next, 2b square as it is, 2k square means this square is for both 2 and k. So 2 square value 4, k square as it is, right? Next, if we shift 2 to the RHS, what it will become? B square is equal to 4k square by 2. So 2 ones are 2 twos are. Therefore B square is equal to 2k square. For this B square, 2 is one of the factor. So see here, if 2 is a factor of a square, then 2 divides a square, also 2 divides a. Likewise, if 2 is a factor of b square, therefore 2 divides b square, that implies 2 divides b, right? So this is from theorem 1.2. Next, so from both equation 1 and 2, we came to know that, see here, from equation 1, 2 is a factor of a, right? Then from equation 2, 2 is also a factor of b. That means both a and b have the common factor 2, right? So what is our condition? A and b should be coparents. That means a and b should have, what is our assumption? A and b should be coparents. That means a and b should have common factor 1. But from equation 1 and 3, we came to know that a and b have common factor 2, which is false to our assumption, right? So root 2 is irrational. So from equation 1 and 3, 2 divides A and B, right? So see here, from equation 1 2 divides A, from equation 2 2 divides B. That means both A and B have common factor 2, which is contradiction to our assumption that, what is our assumption we have took? Root 2 is, that means both A and B are common factor, which is contradiction to our assumption that A and B are co-primes. So what is our co-primes? Co-prime means the common factor should be 1, but we have the common factor 2. So that means what we have considered root 2 is rational, that is wrong. Therefore root 2 is irrational. Hence proved.